left of section 4.1 for divisibility, and then we're going to move into 4.2, which takes some of these ideas and extends them a little farther. So last time we were talking about some different divisibility ideas, and we have just a couple left to do. So example 6 says to answer the following and then to justify the answer that we have decided. So first part on part A says, if the number is divisible by 5, can it be divisible by 10? So, yes. So it can be. Doesn't say it has to be, right? But can be. Yes. Justify your answer.
Because 5 is divisible with 0.
Okay, so can you give me an example?
30. Like 30.
100. Anna says 100. For example, 100 is divisible by 5. And also divisible then by 10, right? What if I took the word can out and I said just that it is? If the number is divisible by 5, then it's divisible by 10. That would be false. And you can give me an example of 15. 15 would be divisible by 5, not divisible by 10. Okay, so be real careful on the word choice that's used. Can is different than saying it must be or would be or something like that. Okay. Second one, if a number is not divisible by 10, can it be divisible by 5? Yes, and that's actually the same kind of question as part A, right? So let's give an example. 25. Yes. So 25, well, let me put an example like I did the last one. 25 is not divisible by 10, but it is divisible by 5. Okay, so you should be thinking in terms of examples when you're looking at these. You're going to have several where you're going to have to answer a yes, no question, or a true, false, kind of question, and justify what you've decided to answer. Okay, we've got one more. All right, a number in which each digit except 0 could have this property, but it doesn't have to, appears exactly 3 times, is divisible by 3. For example, 777,555,222 and 414,143,313 are divisible by 3. So do you understand the description that they gave you? Every number that's in there is there twice. So it's easiest to see in the first number, right? There's 3 7s, 3 5s, 3 2s. Okay? But they don't have to be in order. It doesn't have to be grouped that way. So in the second case, there was 4 1 4 1 4 3 3 1 3, but there's 3 1s, 3 3s, and 3 4s. Okay? So it is a true fact that if you've got them in these groups, if there's 3 items there of every number, and again, 0, they can work or not work, doesn't matter. If that property holds, then this number will be divisible by 3. Okay? The first says, for A, explain why this statement is true. Any ideas? Yes, it does. That is along the right idea for it. So let's take into consideration what was our divisibility rule for 3? Do you remember?
Add them all up and then they're divisible.
Okay, so let's take one of these. Let's just take the second one, okay, and add them all up. So if I added up 4 plus 4 plus 1 plus 4 plus 1 plus 4 plus 3 plus 3 plus 1 plus 3. You can regroup these, right? That community property, so we could actually make it look an awful lot like it that it did on the 777555222. Yeah. I could put all the 4s in the front. I've got 4, 4, and 4. There's 3 of those. I have 1, 1, and 1. There's 3 of those. And I have 3, 3, and 3, and there's 3 of those. And what Lauren just said is that repeated addition, which is what this is, can be written as multiplication. That's what you said, right? But not this one. Okay, So there are three fours. So this is 3 times 4. This is 3 times 1. And this is 3 times 3. Each piece of this has a factor of 3, doesn't it? Yeah, of course it does. Well, if they each have a factor of 3, then if you add them all together, the whole thing will have a factor of 3. We had a property way back at the beginning where this talked about this. It was up here. It says, and this of course did this just for 2 numbers, but it said if each of the 2 numbers are divisible by 3, then their sum is divisible by 3. Well, that's what we've got going on here. We have each one of these components being divisible by 3, so the sum, when we add them all together, is going to be divisible by 3. Does that make sense? So the fact that they're occurring in groups of 3 matters. Groups of 2 wouldn't work, at least not all the time. Okay? So this is going to work because each, let's say each value, each number is divisible by 3. So by, I think we had a name for it, theorem 4.2 part A. The sum is divisible by 3. Does that make sense? By 3, so. Yeah. When you write sideways on the board, this isn't right. That's the things blend together, so they wouldn't put one on the.
What is the rest of it say?
It says it works because each number is divisible by 3. So by theorem 4.2a, the sum is divisible by 3. That's what theorem 4.2a says, is that if you had each of the ones individually divisible by 3, or they did it in general by d, then the sum would be divisible by d. Okay, so that's one statement. This works if I have this property, I do have a number that's divisible by 3. Must this statement be true for any number to be divisible by 3? Okay, why not, Rachel?
As long as the sum of the number equals a number that's divisible by 3.
Okay, so can you give me an example more? So must the statement be true? The answer is no. Give me an example. What you've got to do is you've got to be able to create an example that doesn't have this property and still is divisible by 3. What do you want to do? 213. So is 213 divisible by 3?
Yes.
Yes. How do you know?
Because 2 plus 1 plus 3 is 6.
Right.
6 is divisible by 3.
You got it. So that's the divisible rule for 3. And it doesn't have the property that's talked about in this problem, right? It does not have every number occurring 3 times. But it still is divisible by 3. So this property is a property that works, but it's not a property that has to be true for it to work. That's a little bit of difference. Okay, that's it for 4.1.